Good afternoon, everyone. Thanks for turning out. This is my 5th year in a row at reInvent. It gets bigger every year. My ability to be in the right room at the right time has got worse over the years, so it's quite lucky that I actually found the room in time. I'm David Langton. I'm Product Director at Matillion, and I'm also joined today by Ed from Clutch, who's going to talk a little bit about some real-world use cases and inject a little bit of reality into proceedings. So let's take a quick look at what we're going to cover over the next 45, 50 minutes or so, and we definitely want to save sort of 10 minutes at the end for questions and answers. So anything you think of as we go along, please field. There'll be somebody around with a roving microphone. So we're going to talk a little bit about the end game, if you like. That is the reporting, business intelligence, machine learning, the things you want to do with your data. But really, we're going to spend most of the session taking a step back from that and talking about actually preparing data for machine learning, AI, and reporting, and that kind of thing. So we'll lead you right up to the point where you're ready to go, hopefully. Most of the effort of doing these kind of tasks is in the data prep. You've got data all over the place. It needs bringing together, it needs cleaning up, before you can then present it to a model and expect to make good predictions. We're going to talk a little bit about the challenges of big, complex data. Now, personally, I think of big data as semi-structured rather than huge in volume, but of course, it tends to be both. So strategies for dealing with that are quite important. We're going to talk about choosing a cloud data warehouse and why you might want to do that. But then I'm going to go on and show some examples via some videos of actual real-world transformations of some actual data sets, getting it ready for machine learning. So I just want to spend a couple of minutes talking about Matillion. That's the company I work for and the sponsor of this session. We actually had a managed BI company a few years ago. So every client that came to us needed a data warehouse, easy, or certainly easy on AWS, a few clicks and you provision a Redshift cluster and away you go. They also needed a front end to generate reports and graphs and charts and that kind of thing. Again, there's dozens of those you can just get off the shelf, plug them in, and they just work. The pain we had was on the ETL, or the extract, transform, load. An empty warehouse is no use to anybody. And the challenges we had is that there were plenty of tools on the market that promised to do ETL. None of them were built for the cloud, even though some of them were happy to run there, and it just didn't feel a very natural fit. So we created Matillion ETL as a replacement for our ETL layer, and when it reached a certain level of maturity, we started selling it on AWS Marketplace, and that's where you can get it today and elsewhere. But I've already sort of lied to you a little bit. Matillion ETL is not an ETL tool, it's an ELT tool. We don't market it as an ELT tool because we have to kind of satisfy the Google search gods who still consider ELT a typo. But genuinely what we do is extract, load, and then transform. That's possible now in a way it just wasn't a few years ago. The features of modern cloud data warehouses go way beyond what they did, sort of 10 years ago. They natively understand semi-structured data and have all the functions available for dealing with it. They're also able to reference external data on cloud storage, so you don't have to ingest all the way into physical tables to be able to reference other data. And so it actually makes them a really powerful engine for doing data transformation, not just for generating reports. So you're actually here to find a little bit more about reporting and MI and ML and that kind of thing. But to get us to that point, let's just build up a few levels of maturity. The first thing most businesses start with is static reports. And actually, years and years ago, mainframes in basements used to churn out reams of that, paper with the little holes down the side. Someone would distribute that up to the rest of the building. Nobody would have a computer on their desk, and somehow the world just about kind of worked that way. That didn't last forever, and eventually people got computers on their desks. And then business intelligence and OLAP came along, which kind of changed the game. Suddenly, you wanted to analyze data and not wait around for the answers, not get it mailed to you tomorrow or next week, but while you were sat at the terminal. OLAP, when it was new, was kind of confused with the sort of technology that was surrounding it, and then it just became a more general term for that concept of analyzing data in real time. Now you don't even hear about it very much, because that's just what everybody expects to be able to do. And so you should as well. But with all that maturity, there's still a human being sat in front of a computer, and they're seeing patterns in data, exploring them, drilling into them, and then making a human decision, and then seeing what effect that has. If you're running a business with a few dozen customers that are each transacting millions of dollars, keep the human being in place, it's probably a great idea. If, on the other hand, you're doing millions of customers that are each transacting a few dollars, having the human being make the decision will destroy any margin you might have had from those customers anyway. And that's really the sweet spot for machine learning. It's the lower value decisions, but you want to automate them because you're making those decisions millions and millions of times. If that sounds really, really modern and really recent, credit scoring models based on inductive decision trees were one of the first uses of computers in the mainstream in the 60s and 70s. This isn't actually that new. What's different is you could probably do on AWS for $1 what used to cost $10 million in the 1970s. It's just completely changed the game. And then machine learning is just a subset of AI. AI is much broader, and I'm not going to cover it too much today. But the one thing I do want to say is AI is a really useful pre-processing step if you're in the data warehousing game. Because if some of your input data is kind of maybe binary, let's say you've got users uploading images to your website, you don't really want to put the images in the data warehouse. You can't really query them, but you can get an AI model to add tags to them, and the tags can be warehoused, and then you can identify the users of your site that predominantly enjoy images of cats, for example. But enough about AI. The business value in doing some of this machine learning, well, really, if we take the assumption that it does add some value and your competitors are trying this, then if it really works, you're going to be left behind. So you probably want to start considering it yourselves. But you can't just feed all of your business's data into one big model and ask it, how do I be more profitable? It's not that simple. You've got to be a little bit targeted. So what you really need is a base layer of reporting that's measuring key aspects of your business, your customer's life cycle, the manufacturing life cycle, whatever it is that's important to you. The reporting will help you focus in on areas that are underperforming and you might want to deal with. So if you think that you can attract lots of new customers, that's great. If you're losing them just as quickly out of the other end, you probably want to build an attrition model and try and learn why. If your customers are really sticky once you've attracted them, but you're struggling to find more customers, then actually some models about acquisition are probably more likely to be of benefit. You also might be fooled into thinking that these models that you build have to be really, really accurate. And actually, they only have to be marginally better than guessing to give you some benefit. And then the better they are after that, the more value you get from it. If a customer leaves and they take that revenue stream with them, that's not good. You've lost the customer, you've lost the revenue. If you can offer them just a small incentive and that's enough for them to hang around, then you should probably think about offering that incentive. But if you just offer the incentive to every customer, most of them would have stayed anyway, and you're just burning through margin at that point. So there, the machine learning aspect is, tell me which customers need that little bit of incentive to stay so that I'm far more targeted. It's a pretty common example, but it's still a useful one. So where should you start your journey? Well, we've kind of said reporting to focus in on which area to do model building. But before you do either of those things, you need a data strategy. You need to think, where is my data coming from? How am I going to convince people that it's clean, that it's useful, that it's valuable, that it's audited, for example? You kind of need to be able to say where the data came from, not just, it works, trust me. So really, my starting point is with a data warehouse. A data warehouse is what is going to be the source of truth, hopefully. So before I go into some of the examples and show you some demos, I'm going to hand over to Edward, who's going to talk about Clutch's use of some of this stuff in his business.
Thank you, David. As he just alluded, Edward Hunter. I'm the Director of Business Intelligence and lead of data engineering for Clutch. Clutch is a loyalty customer platform in the retail space with the goal of identifying, understanding, and motivating consumers to behave in particular ways that are advantageous to our brand clients. In our space, we deal with challenges that I think David alluded to earlier. Our brands don't have a few customers transacting a lot of money. They'll have thousands or millions of customers transacting not only variable amounts of purchases, but also the amount that they purchase at any one time. You might call that basket size, is also highly variable. And we deal across a variety of different verticals within retail. These all compound a variety of challenges, and our end goal, which is to be able to create an ecosystem where our brands can move customers with lower reach, frequency, and monetization up into higher reach, higher frequency, and higher monetization segments. And to Dave's earlier point, at scale, this isn't something humans can do. Not the most intuitive, not the most skilled marketers can wrangle that kind of volume of data and make cogent, intelligent decisions about where to spend their money, where to market. And so when creating models for our customers, such as future lifetime value or the journey of a customer through the ecosystem of one of our brand clients, or just being able to articulate the current state of the relationship between a brand and one of its consumers, we face a set of challenges that really kind of push the limits of what some of these edge technologies can do. And so we needed to solve these problems in a way that maybe hadn't been approached in the marketplace before. And that is what sort of led us to AWS, to MPP databases like Redshift. And in doing so, we began to recognize the need for a new paradigm in the tool sets that we use to manipulate this data and navigate some of these challenges, which I think some of you out there will share some of the challenges that we face. Some of you will encounter many of the challenges. Our sort of mandate has been that we're equipped to deal with any of the challenges, and some of them are fairly formidable in terms of not only the scale of the data, but also the composition and the context of the data. So, for example, everybody deals with different data sources, whether it's CSVs, different delimiters, different data types, tabulated data, Excel data. We've all dealt with the differences in and the nuances of materializing different data types between numerics and strings. One of the challenges that we have at Clutch is that the language a lot of our brands will speak is completely different from one another, even though they're all dealing with, a brand to a very granular level and high volume of consumers. The language that they're speaking to these consumers might be completely different. So for example, in automotive, attributes our customers might be dealing with could be makes and models of automobiles, dates of purchases, the last time a muffler was changed. In clothing, we have sizes and color preferences and purchases that are made for children or adults. In the grocer verticals, all of these customers that we have are sending us data with the intention of achieving the same goals, understanding their consumers and moving them up more positive segments of doing business with them, and wanting to apply our ML models to this task. We obviously can't have a platform that looks differently depending on what vertical you come from. So a big challenge for us is being able to pull all of that data together and speak a common language across all of those attributes, so that we don't have to write the book over and over again for every customer that we do business with. And that's actually sort of where we came from, is in dealing with our customers, each sort of customer had its own set of challenges, so we did what a lot of people will do. We started writing code. We started writing sort of unique Java components that would deal with a particular set of attributes for a particular vertical. And as we started to scale out and acquire more customers, acquire and enter new verticals, we started having the realization sort of that a lot of these components could never be used for other purposes. So we had this growing code base of very task-specific ways of dealing with our customers' data. And in terms of our ability to be agile and bring our customers to market, we started noticing a marked decline in our time to market for our customers. And if you're a retail brand, you're already in trouble today. Last week, a major retailer shuttered its doors with over 150 locations. Next week, it'll probably happen to somebody else. And so trying to be sort of the champions out there in retail means that we have to act at speed, and we wanted to choose a data warehouse that was not only allowed us to capitalize on our existing subject matter experts that dealt with data and have been dealing with data for decades, and not have to reinvent the wheel, but we also needed to be sensitive to things like privacy in the retail sector. When our brands are doing business in the digital space, they're doing brand business in the terrestrial space, if you will. We had a lot of considerations for how to store that data, how to access that data, how much data to store live, how much to sort of have at rest. And all of this played into the requests we were getting from our data sciences team to take data that might come from one retail vertical and another retail vertical and make the same models work, right? Be able to predict the future lifetime value of a customer, regardless if that customer is buying, Legos or T-shirts or mufflers. And this was a challenge for us in the sense that we knew we couldn't achieve those goals by continuously rewriting components individually for customers that we would then not be able to translate over to use with other customers. And so aside from the AWS platform kind of being a natural fit for us, having come from MPP databases like Greenplum and whatnot, the ability to sort of silo our customers' data, on S3 and equip it with pretty solid encryption all the way across the wire as it made its way back and forth between at rest and database. These were all considerations that made the AWS platform a pretty natural choice for us. So when our data science team comes up with ML and AI, a lot of data scientists will say, well, it's better than a coin toss. That sounds great to me. I mean, if you give me a result and you go, well, you flip a coin and this result will be better than that coin toss. What we found, though, was that people spending money at brands didn't seem to find that all that impressive. Better than a coin toss was not a strong value proposition for marketers. You were trying to say, you need these models to transact your business, to conduct your marketing. Your gut instincts and what you read, in Adweek last week isn't enough to fuel a concise strategy. So we needed outcomes that we could prove. We needed outcomes we could document. And we needed a lot of this. So in our ecosystem, imagine that you've got a percentage of our retailers who are connected to our API. So their point of sale systems are literally routing their data directly into our platform. I'd love to say that retail is the type of space where everyone can do that, but I'm being honest when I say that if they were, retail probably wouldn't be in as much trouble as it is today. The fact is, retail has been slow to move forward in the technology space. Some retailers, POS systems are in malls in rural areas that still don't have internet connectivity, that can't transmit data in real time, that they have to send us batch files that come to us via SFTP. When you have a data sciences team that is hounding you for normalized data that they can build classification and algorithms off of, and you're having data thrown at you where not only would the attribute mix from one brand to another be vastly different, but there was nothing that said that they couldn't continue to build on these attributes over time, especially when they started marrying them to data from social and data from other systems, IBM Watson and whatnot. So it was a real uphill battle for us that we solved the majority of it with a solid data warehouse on the AWS platform, but we needed more than that. And the more we started relying on Java code and custom components to work with our customers' data, the less agile we became. And when our processes broke, often our data scientists wouldn't know this until their algorithms fell apart after hours and hours of processing and testing. So the situation for us was kind of, we needed to go back to sort of the RDBMS world of ETL, where you could use subject matter experts in moving data around and transforming it. But when we went out into the space, what we found was that there were a lot of solutions out there for moving data around, a lot of data solutions for transforming it and manipulating it. But one of the biggest things that we ran into was that all of these required our existing SMEs to become subject matter experts on some sort of custom piece of software that often came from a paradigm that wasn't really traditional ETL. It was sort of a blend of sort of pipelines and things that really required them to become experts in tool sets to get a job that they were already sort of subject matter experts done and accomplished in. And so the tools didn't really translate to what our guys were used to using, tools like Informatica's suite of ETL or SSIS by Microsoft. And in order to capitalize on that sort of incumbent subject matter expertise and get these data models prepared, whether it was for visual reporting, our front end, client-facing reporting, these massive ML, patterns that our data scientists were coming up with, we really wanted to come up with a tool set that would get the job done, allow us to repackage and reuse the functionality we'd use to accomplish the goal across a broad cross-section of our customers. Now, I will wear an AWS t-shirt to Denny's because I'm that big of a fan. I thought that when it first came out that it was for the first time the ability to open a toolkit and reach in and grab just the right tool for the job. And they just kept coming out with new tools to do the things that seemed to answer the call. A lot of them came out in a very timely fashion, sometimes so timely that they would come out right after we had completed development of a tool using their components that would do the same thing. And another caveat was that some of the components that we tried to use in the AWS platform worked really well, but they were complicated enough or sort of narrow enough to where we couldn't apply them as broadly to the use cases as we wanted. So they just didn't give us the agility that we really needed to get the job done in a repeatable, reusable way. And so we decided to go on the hunt for some supporting technology to assist us with this. The bar, if you use Redshift and you don't use, say, Snowflake, the bar for you is different today than it has been for anyone working with column and table-based data ever in history. Most of the time, there's been a really clear separation between the Transact SQL guy and the database architect and the DBA or the server engineer. Well, massively parallel architecture changes all of that. In order to be really good at it, you have to understand the nuances of what's going on in both worlds. Properly designed tables. Tables that are leveraging the node structure of your cluster properly and distributing the data so that you don't have a bunch of crosstalk as the engine tries to solve your queries by polling other nodes in the cluster for the data to solve the problem. You need to be more today. You need to be an engineer. You need to be a DBA, kind of. You need to be an architect and a table and database designer. You've got to have your security chops. And so when you come up with that kind of challenge, you don't also want to dump on the problem of, okay, and now to actually work with our customers' data, you have to write all of these custom things in Python or Java, much of which you won't be able to pull out of the tool bag ever again because they just simply don't apply. And so after reviewing a lot of the tools out there and just sort of looking at them and saying, how much of an expert do I need to be in this tool before we can actually address why we're looking for the tool to begin with, right? And I feel like that's a lot of the tools that are out there. They sort of assume that you have this knowledge of how their tool set works when you're really just trying to translate it into how do I get this data? How do I do stuff to it? How do I move it someplace else? And so when we started looking at Matillion, one of the first things that really struck us about it was that it natively speaks the language of Redshift, for example, and S3. So show of hands here, who has copied data into Redshift? Anybody? Okay. So when you're copying data into Redshift, there are several choices you make that change the availability of other options that you have, right? If you choose a delimited file, all of a sudden there's other options that you have to configure in addition to that. Or if you choose not to do a parallel unload of the data, then a bunch of the other options are no longer relevant. And these are nuances that, if you really know your chops, you know all of this stuff. These are also nuances that we really expected any tool set that we worked with that dealt with Redshift to also understand. And this is what we found when we started working with Matillion. In addition to the ability to quickly configure routable jobs and tasks, much like you might see in Informatica or in SQL Server's SSIS, the components that we started deploying, we noticed minimized our need to sort of futz around getting them configured right, because they would sort of say, oh, you're using this type of file, and it's limited this way, but here are the other options that you need to be focusing on. And so we ended up building a lot of our processes to read in data, make changes to it and load it into other data models so that it was accessible by our reporting models and our ML models, using this tool and really pushing it to its limits with a lot of help from the Matillion customer service team, which is fantastic. I think to show you some of how that looked for us and sort of some of our journey through that, I'm going to turn it back over to Dave to demo out some of that stuff. So Dave?
Thank you. So yeah, we've talked quite a lot about BI, ML, and now obviously data warehousing. I would definitely recommend putting that layer in rather than trying to skip over it and put data directly into a model. And you definitely want to make it a kind of repeatable flow so that when it works, when new data arrives, you can just push it all through the same pipeline, which is something you can't do if you click around the console and build things that way. It's a great way to learn, nevertheless. So I think in terms of the other tools, I alluded earlier that there are a bunch of tools. I think you just mentioned Informatica. There are others. They weren't built for the cloud, even if they're being sort of pointed there. And because they're ETL, you need to build and manage the infrastructure, temporary and scalable though it might be, to actually handle the transforms. Whereas doing ELT, where the transform's done by the data warehouse engine, well, if you've scaled the data warehouse engine to cope with the amount of data, you've also scaled it to cope with the data transformation because it's the same data. So we're going to look at an example to highlight that if you think the problem that you're avoiding by not having a data warehouse layer is that it's difficult to get data in there and difficult to manage it, it really isn't. This is actually real data, but I've chopped a lot of columns out so that nothing can really be identified. Every time Matillion sends an outbound email, it goes via Amazon SES, the simple email service. And sometimes, for a variety of reasons, those emails bounce. And it'd be kind of nice, maybe, to be able to predict that and not send them in the first place if the chances of it bouncing are so high that it's, almost certain to never arrive. That data could come from all sorts of places. If we just watch this video, in this particular case, it's an RDS database. So somebody's already taken the trouble. Oh, hang on. I apologize. I'm not sure why, but these videos are out of sequence. Let me just see if I can pivot to the right video. Sorry, I'm going to have to hop backwards and forwards a bit. Here's where we're really going to load the data. Yeah, that's working now. Apologies. So all we really need to do in Matillion is create a job, find the component that understands your source data. In this case, it's coming from RDS. There's an RDS query component. There's about 70 or 80 other data connectors for APIs, file formats, and other services. RDS is quite a simple one to get started with. And because Matillion, in this case, is running in your Amazon account, it's not a SaaS tool. You install and run it in your own cloud environment. That RDS can be in a VPC. Redshift can be in a VPC. And then the data never leaves the VPC, which is kind of nice to know that you're fully in control at every stage. And what the component actually does for efficiency is it extracts the data from RDS, it formats it into objects, a number of objects on S3, and then asks Redshift to do a sort of parallel ingest across those files. It essentially follows the Redshift list of best practices without you having to really know what they are. So we just need to kind of configure the right options to point it to the source table, any filters we might want to apply, any columns we're bringing across. As I said, this is a very small list of columns because I didn't want to give away any PII data like email addresses, although of course that was in the original source. These are bouncers after all. And then that'll get ingested into Redshift. That is to stop any annoyance of the DBA who doesn't want analytic queries running on a transactional system, and I would support that. That is a fair ask. The other advantage to this, of course, is your other data sources that you might want to mix in with this are probably in other databases, and you need to get them into one central place, ideally. And so there we have, I think I limited it to 10,000 or 100,000 bounced emails. We send a lot of emails. And that is as easy. That is now sat in Redshift ready for the next phase. So just bear with me while I flick back to the correct slide in the sequence. So let's say we've done that a bunch of times. We've brought in many different data sources that are all in some way related. Let's talk about transforming that data, firstly for data warehousing in a traditional way, and then for machine learning and see what the differences are. So when you're transforming data for a data warehouse, you're mostly concerned with transforming the shape. The data's come in from all sorts of different sources. It needs cleaning up, it needs joining together, it needs new fields calculating, but then it goes into a particular shape. Now, there's a few options available. The shape on the screen on the left is a star schema. So you have a fact table with a bunch of foreign keys and some numeric facts, and then those foreign keys go off to all the things that describe where that data came from. Employees, products, customers, that kind of thing. In terms of the new calculations in your fact table, maybe the source data has a quantity and a price each. Are you really going to expect every single person who's using that data to multiply them together to come up with the value of that line item? No, you're going to calculate that up front and put it there as a column, and then everybody uses it and nobody disagrees with the data. Hopefully. When you go over to the ML side, you start talking about feature engineering, and it sounds like something completely different, but for the most part, feature engineering is creating new values or newer attributes from existing ones. It's almost the same example as I just gave, where you've got two inputs and you want to multiply them together because that's what you believe the model might want to see. Of course, it gets a little bit more complicated than that. So, I'm going to put the two things together, the fact that we want a dimensional model and the fact that we might want to do some data transformation for ML. And in this next clip, is it the next clip? It might be the next clip. Let's go for it. So I'm going to create a... No, it really isn't the next clip. Not back far enough. Apologies. Okay. Bear with me. We just loaded the data, I think. Now we're going to prep it for some machine learning. Now, there's a column in this table which you're going to see in a few seconds. We're going to bring this data into a transform because we're going to manipulate it and play around with the data a little bit. The very first column is a timestamp. Now, if you present a machine learning model a timestamp, it's not going to do anything very special with it. In fact, it's probably going to throw it away because every value is unique, and that's not really any predictive power. But because we're working here in the context of a data warehouse, we already have an existing date dimension that for every possible date we're ever likely to encounter, it will tell us what day of the week that was, what month of the year it was, whether it was a weekend or not. And it'll do that all as nice, as you can see, numeric attributes. They are very good potential predictors in a machine learning model. So they're the kinds of fields we want to pass on. So because all this data is coexisting in one data warehouse, all we really need to do is join the two sets of data together, swap out the original timestamp with all of these attributes, and then pass that downstream to the machine learning model, which is exactly what you're seeing on screen now. So we can just quickly bring in one set of data and join it to the other. Now, actually, I think in this case, we're dealing with a timestamp in one data source and just a date in the other. So the join has to truncate one side in order for that to be successful, but that's not particularly difficult. So yeah, we'll truncate the timestamp and match it to my date dimensions, date key. Take those columns through. And now, in addition to the timestamp at the front of the data set, we should see all of those attributes come through as well. And there we go. Now, those original dates and timestamps aren't any further use at this point, certainly not to the model. We could keep them. In this case, I'm just tidying them up and removing those columns. And then all we really need to do then is write that out to a new data set, and that is the table that we'll want to present to any potential machine learning algorithm. When that finishes running, we've now got a data set ready to go. None of this takes very long either, I hope. I mean, that was playing at kind of real speed. Although it's fair to say I do know the tool fairly well. I don't think it would have taken anyone very much longer to get to that point. I certainly hope not. So let me rejoin the right place. Yes, excellent. So there's a lot of modeling tools in the ecosystem, and I've just pulled out a few just to discuss now. Amazon SageMaker is, if you get a notebook server up running SageMaker and you ever did any machine learning before it existed, it's a step change in terms of simplicity and getting started and really getting up to speed really quickly. And it's completely flexible. So there's a bunch of built-in models. You can build your own models, and you can buy models from AWS Marketplace. So it's really flexible, as well as being pretty easy to use. But if you thought the old tools were difficult to use compared to SageMaker, then the even newer tools like Amazon Personalize and Amazon Forecast, they're a step change again in simplicity, where all you need is a few API calls or a few actions in the console. And because they're specialized to a given use case, they're even easier to use again. And we'll have a bit of a look at one in a second. Now, Personalize is the example we're going to look at in a moment. But before I look at it, I need to describe the sort of series of actions that you need to do. So we've got a data set. It's sat in Redshift at the moment. It could be another database. It could be Snowflake, for example. That would be fine. In order to use that with Personalize, requires a few steps. So if you were using the console or the API, you would first create a dataset group, which is just like a placeholder to hold data. You then need to provide an Avro schema file, which is already starting to sound slightly annoying if you don't know what that already is. That describes the format of the input data that you haven't even created yet. Then you can create a data set, but weirdly, that's just an empty data set that refers to that Avro schema. And then fourth and finally, you can actually ingest data from S3 into the service as long as the data matches that schema file. So that's all, straightforward, I guess. I'm going to go backwards this time, and maybe that'll give me the right video to play. Now, it's pretty unlikely that any off-the-shelf ETL tool will understand every AWS service. And in fact, you can see on this video now, I am trying to search components for Personalize and not finding any. But Matillion also has this concept of shared jobs, where if anyone else in the world managed to figure out how to build an ETL job that can go all the way through to Amazon Personalize, they can share that and you can all benefit from it. And so we do, in fact, have a create dataset group and a create dataset component that, as an end user, you don't need to understand Avro schema files. You don't need to understand the series of API calls. All you really need to know is you need a dataset group and a data set. And the ARN that is created from the group needs to be passed in to the create data set, which is why they need to be broken into two components. That and the fact that you might register many, many data sets within the same group. So that's what we're doing here. If you want to go into the shared job and actually understand how it's working so that you can learn from it, tweak it, change it, or write your own, you can do that, and this is just showing the underlying job that was created that became this shared job. And what you'll recognize there is we're putting the data on S3 in one stream. We are introspecting the Redshift format of it in another stream, using that to create a schema. This is done with a bit of Python code. We're then registering the dataset group and ingesting the data. You don't need to know any of that to use it. You just press run, and what you end up with is the data ready to analyze in personalize. You can do a similar thing for all the other services, and that's just to get you to the, from data ingestion and preparation and pushing it out to the modeling tools in one flow. Why is that beneficial? Because when that new data set arrives, you want to do all of those same steps, but you want it to just be automated and know that it's following the exact same process as before. And if I skip over the videos that we shouldn't have been watching earlier, I'll hand back to Edward for some next steps on Clutch. And then I'll pop back just at the end. Thank you, Edward.
Thanks, Dave. So, having solved a lot of the challenges with having to kind of reinvent the wheel for each of our clients, we've become a lot more agile. Our time for onboarding our customers has dropped, by almost 75%. We're able to write extraction and transformation and load components that we can apply to other customers, in a couple of days and not a couple of weeks. We don't have to maintain a repo of dozens or hundreds of different distinct, pieces of code that are designed really to do only one or two things. But since then, what we've started doing in a very sensitive to privacy and clean way for our customers is we've been able to leverage Matillion's ability to reach out to really name it, Marketo, Dynamics, Salesforce, Marketing Cloud, Facebook, LinkedIn, Twitter. If it's a social service out there and you're doing attribution, the ability to connect the dots across what our customers are providing us from their point of sale data or their loyalty data and what their customers are saying out on the digital web or how their sentiment might reflect their experiences with the brand is literally the key for retailers keeping their doors open, keeping their locations open, or not. Today, it's a very cut and dried scenario for them. They are either succeeding in their marketing efforts using data or they are shuttering. And so we've had a lot of success in helping them bridge that attribution gap. But let's face it, with California's new legislation coming out in 2020, with GDPR heavily restricting the use of privacy and personally identifying information, which they should, it becomes harder every day for brands to really safely connect those dots unless they themselves have the infrastructure and the capability of launching those initiatives, and they're just not technically savvy enough to do so. So what's next for us is that we've been helping them safely bridge those gaps between the data they've collected legally and safely and the data that is in the social networks without actually transacting any of the personal information back and forth, using techniques like MD5 blind hashing of personally identifying attributes and joining those up so that no personally identifying information can ever be discerned from what's being used in the match, to fueling some of the new state-of-the-art machine learning algorithms that are using arrays of attributes that were well beyond the reach of any retailer 12 months ago, 24 months ago. And being able to do that and being able to not answer a customer by saying, we'll have to get back to you. Can we do that for you? We're not sure. We'll have to. And being able to say, you know what? We can do that. We can connect those dots for you. We can automate this in a way that's secure, protects your consumers, and gives you, chain of authority over your data, and gives you more than just a coin flip in making your decisions when the life of your brand is at stake. This tool set that AWS has provided us and folks like Matillion have made it so that we can focus on bringing those benefits to the retailer to help them stay alive in a space where they're being cannibalized by really everything. We're entering sort of a new age where rather than having developers spend all of their time creating ways of just accomplishing the basics, we're now innovating ways of connecting the dots that couldn't be connected before. And at least for our customers, this is a real game changer, and in a large part due to its efficiency, the way that it's built, and the support of its customer service team. We have the Matillion ETL tool for Redshift to thank for this. So thank you. I think we're going to open it up for questions.
Yeah. If there's any questions at this point, we'll be happy to field them. And while some microphones are circulating, if you want to kind of get a proper demo that's a little bit more tailored to your use case, come and find us on booth 2804 in the main expo hall at the Sands. I don't know why I mentioned 2804. If you walk into that room and can't find a Matillion booth, see an optician. It's enormous. We've got demos going to a theatre style on all of our main products. We can also organize a one-to-one demo of a solution architect. There's loads of swag being given away, and I believe there's a daily draw for wireless sunglasses, which audio, it doesn't even make sense to me, but they're expensive.
I thought those were for me. Anybody have any questions that they want to pose to us before we wrap up the session today? Thanks, everybody, for coming out.
Yeah, thank you.